Hey Dr. Zhang, today I'm going to be verifying the hydrostatic equation and principle by using a siphon. Okay, let's get right into the experiment. I have a simple cup of water and a tube to act as my siphon. And the way a siphon works is by height directly affecting pressure. So whenever the water level in the cup and the water level in the tube are the same height, the pressure is equal and the equilibrium keeps the water in the same spot. However, whenever I dip the water level of the tube below the water level of the cup now has a higher pressure than the tube. So water tends to flow from high pressure to low pressure, and when that happens, the water pours out. Now to the math. Okay, first let's start off with our knowns. Our gamma of water is approximately 9,800 newtons per meters cubed, and our height of the water is 0.05 meters. We have the height of the tube, but we're going to get into that for our second equation. First thing we want to do is solve for the pressure at the bottom of the cup. And the reason I want to do this is because I put one end of the tube at the closest to the bottom of the cup as I could, so that I could accurately calculate the pressure next to it and compare it to the pressure at the end of the tube. To do this, I use the equation P2 equals P1 plus gamma Z. We're going to substitute everything in, P1 being 0 because it's the bottom of the top of the cup, open to all air. We get P2 as 490 pascals. Okay, so what we want to do with that is substitute it in for our equilibrium equation in hopes that our P1 is less. And once we do, substitute 0 meters in this time because our P2 is at the bottom of the cup, and 0.04 meters in for our P1 because our water height is 0.05 meters, I use 0.04 meters for the top of the tube just to show that just a 0.01 difference in height will cause a lesser pressure at the end of the tube. Okay, so once we do substitute all those numbers in, we come out with P1 equal to 98 pascals, and that does confirm that the water should flow from our greater to lesser pressure, and that it's all good.